About forces and shapes. Forces and shapes. Now the first thing that we need to talk about, that what is a force. Now you have to understand, this is extremely important. A force is a push or a pull. So it's actually a push or a pull. And people have the idea that forces cause motion. Forces do not cause motion. Forces cause change in motion. This is extremely important. They do not cause motion. Forces do not cause motion. Energy causes motion. Forces causes change in motion. So it's extremely important that you remember that. Now when we're talking about force, we have to talk about some very important types of force, right? So what are the push and pull? What are the famous push and the famous pull? The most famous pull is called, let's write types. The most famous pull is the gravitational pull. Another name for this gravitational pull is also weight. So it is the pull, the force that is pulling us to earth, right? That's called the gravitational pull or the weight. So this is one type of force. You can also call this another type of force. Another type of force is the thrust. It is usually referred to the force applied by air resistance or the force applied by water. So together they're called forces applied by fluids, thrust. Then force applied by some sort of a string, that is called a tension. Force applied by a string is called a tension. Then force applied, any resistance to force, usually referred to a solid, when you're moving and there's a solid that is stopping you because of contact force, that is referred to as a friction. So you might call that this is because of a contact force. Surface contact, usually surface contact, we're talking about solids. So these are the different types of forces that we talk about. And there is also some sort of a reaction force that we use if we put something on something because of contact surface, reaction force. But this is, in a nutshell, that's the idea. Now when we talk about types of force, one thing that we have to talk about is the unit of force. Now force, the formula that we use for force is force equals to mass into acceleration. Now we already know what acceleration is. Let me talk about mass. Mass is the amount of matter something is made up of. Amount of matter something is made up of. Something is made up of. So whenever we're talking about mass, we're actually talking about the amount of matter something is made up of. So this is also, the unit is kg, it is a base unit. Just like meter, displacement unit meter, that's a base unit. Timer second is a base unit. So kg is also a base unit. So from that we already know the unit of acceleration. Acceleration is meter per second square. It's a derived unit. So from that we can say force has a unit of kg times meter per second square. That's the derived unit of force. But we usually use the name of a famous person. Famous person, here we call it Newton. It means Newton. Now to get a perspective, if you want to know what is 1 Newton, well, 1 Newton of force is the same as, this is the force applied by one chicken egg has weight of 1 Newton. When you hold it in your hand, that chicken egg, that force that you feel in your hand, that's 1 Newton. Okay, so by definition the unit of force is Newton, but the derived unit of force is kg meter. That's the definition of force. F equals to ma is the formula. Now one thing is important to remember, that force is a vector quantity, meaning it has both direction, that we talked about in the last time. Vector quantity, because it has both direction. What has the direction? This acceleration has both direction, because acceleration is based on velocity. It's a vector quantity, so it has both direction and size. So it has both direction and size. So remember that, direction and size. So it's a vector quantity. Now the next thing that we need to talk about is the concept of balanced force and unbalanced force. Balanced force and unbalanced force. If force is balanced, then we can say that if you have an object like this and someone is pulling here with force 1 and someone is pulling with force 2, and if this is balanced, we will see that F1 minus F2 equals to 0. Net force is 0, so there is no acceleration. But if it is unbalanced, then what would happen is that one of the forces would be more. So in case of unbalanced force, if we have an object like this, if this is F1 and F2 is a little bit less and ultimately it is moving in this direction, it means it is accelerating in that direction. So the net force will be equals to mass into acceleration. So the net force is the larger force minus the smaller force, and that will give you the mass into acceleration. It will be accelerating. So for something to accelerate, the net force has to be 0. That is very, very important. Now in case of force, the types of force are very important, and one of the force we have to talk about is friction. It happens because of surface. So whenever you think about surface, you have to remember that friction can actually reduce the force. That's one of the main reason. The next concept here in force is the concept of Hooke's law. Hooke's law, it's also very important. Hooke's law. So Hooke's law, made by Robert Hooke. So Hooke's law says that whenever we are talking about, let me raise it a little bit, whenever we are talking about springs, so if this is a spring and you have some sort of a force here, so suppose that force, something force. Now originally maybe it was like this without the force, so it was like this, but because of the force there has been an extension, a distance, an extension. Suppose this extension is x. So Hooke's law actually says that the force that you're applying, that force is directly proportional to the extension. So the more force you give, the more it will extend. The more force you give, so it is F equals to some constant into x. That's the law of proportionality. So if you remove the force, it will return to its original position. So if you see a graph here, the graph of extension, let me use the full word, extension, and this is force. So it will be a straight line like this. So it means they're directly proportional. The more give you load for this, load force, L-O-A-D, load force. The more force you apply, the more the extension, and they're going to go on like that. So that's the relationship, that's the Hooke's law. But if you see the entire picture, this is extension and this is the force. If you see the entire picture, the picture would be like this, and up to this point it would be straight line. So you can say up to this point it obeys Hooke's law. So whenever the question is how do you know something is obeying Hooke's law, if it's a straight line, you will say up to this point it's a straight line, that's why it obeys Hooke's law. But after that point it goes on like this. This point where it does not obey Hooke's law, then if you remove the load here, it will not return to its original position. So we call this the limit, the elastic limit. So the elastic limit is the point up to which it follows Hooke's law, but after the elastic limit it does not obey Hooke's law. So that means after that point, after elastic limit, it will not return to original position. So after elastic limit it will not return to the original position. One more thing that must be added is that there is rubber does not obey Hooke's law. Elastic bands are usually made up of rubber. So when you have something for rubber, so the picture would be like this. So this is for rubber or elastic band, which is made up of rubber. So since elastic band, they're made up of rubber, they do not follow Hooke's law and they do not come to their original position.